I wanna pull up, head spin, get flat. I got 6 jobs, I don't get tired. I don't get tired. I don't get tired. I don't get tired. Get flat. I got 6 jobs, I don't get tired. Full-time artist, ex-guard said grind hard, learn from every time you ever fail. If you never fail, just grind smarter. I ain't sharpened, you the dag on their hindquarters.
I guess I'll make a little goddamn video, babe. Alright, what's up, gang? This is the start of Unit 9. This is going to be 9-1 video. Alright, and the things we're going to cover is going to be, and we're going to cover multiple representations of graphs. Alright. Let's go ahead and dig in. This first example here is of a linear function. Alright. And this is broken down. We're talking about Stacy's time. But anyway, a linear function, guys, is a straight line. All right, it's always straight. And right here it says, notice how the y's are increasing at a constant rate. All right, from 13 to 16, that will give you plus 3. All right, from 16 to 19 is plus 3. 19 to 22 is plus 3. And 22 to 25, again, is plus 3. All right. So we can look at this y table here, guys, and see that we added 3 every single time. All right. So what we call that right there is called a first difference. All right. And the first difference, guys, and what that simply means is we just went up. All right. At first glance, that's a consistent pattern. All right. We can see it every time. All right. All right, next we have here is a quadratic. All right, and with this quadratic, guys, we did quadratics. All right, the parabola is a quadratic. All right, but the thing I want you to notice about this pattern is this. All right, it says notice the y's. All right, look at the y's. 3 squared would be 9. Negative 2 squared would be 4. Negative 1 squared would still be 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. All right. Since all these are squared, guys, what we call that is a second difference. All right, second difference. All right. And then right here, guys, and right here it's exponential. All right, with exponential, guys, y'all see this curve? That's a growth. All right, exponential growth. And if you guys remember, we always had something that we call a ratio. All right, a ratio. We find a common ratio. This thing is increasing by common ratio. All right, and there's a couple different things we're going to do with our calculator. All right, so I'm going to show you. Let me get my calculator up. Give me a second. Now, before I click on my calculator, guys, I want you to notice right here that the directions are right here. All right, they are right here, okay? So if you ever get stuck, make sure you return to these directions so you can see how to do this. All right, but the thing we want to do first is make sure our diagnostic is on, okay? Now, let me show you how to cut your diagnostic on. All right, first step you're going to do is you're going to hit second. All right, then you're going to go to option 0 right there where it says catalog. So we're going to hit 0. All right, here's our catalog. You're going to scroll down, all right, until you get all the way to option D. All right. And keep going down until you see right here where it says diagnostic on. All right. Now, once we get the diagnostic on, we're going to press enter one time. All right, and then it's in your main screen. Then hit enter again till when it says done. All right, once it hits done, we are there, guys. Okay. All right, so now let's see. Go back over here. Now we're going to use the calculator, and we're going to work on creating a table. All right, using the graphic calculator. All right. And then we're going to work on these 3 things down here. So we're going to talk about linear. All right, so let's look at the first example, guys. We're going to press stat. Go to your calculator. All right, we press stat. Where are you, stat? Right there. Stat. Then edit. All right, and let's see. We're going to clear our list. Oh, here we go. Clear. All right. Oh, wait a minute. Clear. There we go. Okay. The lists are clear. All right. So we in list one, we're going to put our x values. So our x values were 2, 4, 6, 8, and 10. All right. And over here, we put our y values in. All right. Our y values from the table. This table right here. 13, 16, 19, 22, 25. Alright, so add the values like so. Alright, then back to the directions. Okay, we have them in. Then we press stat again. We're going to go over to calculate. Alright, now since we said it was linear, alright, we go down to what's called linear regression. Alright, linear regression, which is going to be this one right here. Linear regression, alright, linear regression. And I hit enter. Alright, and list one and list two. Alright, go down to calculate. And voila, this is our equation. Okay, you see that says ax plus b. A is 1.5, b is 10. Alright, so we go to we come back to our worksheet. Alright, and we're going to put it in. Alright, a was 1.5, x is x, right? And 10 was b. Alright, y equals, by the way, I'm sorry, y equals, here's our function that represents that graph. Alright, and then the next thing you want to put is your regression, alright, which is your r squared. Alright, your regression is going to be, or your correlation coefficient is 1, guys. Alright, 1, alright. 1 our r squared value, so 1. Alright, now, let's try and look at quadratic. Alright, this is the quadratic function here. Alright, so we're going to go back to our calculator. We're going to press stat. Sorry about that. You press stat. Alright, then edit. We're going to edit our list. So let's clear them both out. Alright. Now, list 1 is going to consist of, in the x column, -3, -2, -1, 0, through 3, alright? All the way like this, alright? -3 to 3, okay? And our y column, guys, this is our y column, alright? It's going to go -9, 4, 1, 0, 1, 4, 9, alright? Alright, it should look like this, okay? So go ahead and enter those in, guys. We'll pause right for a second. Alright, you should have this in your calculator. Okay, so now let me show you now. We press stat again. Alright, now we know that this is a quadratic. So we go to calculate. Alright, then we go to quad regression, option 5. Alright. And list 1 again. Y2 is list 1. Y is list 1. I mean list 2, excuse me. Press enter until you get to calculate, and then hit enter again. Now, a quadratic, guys, remember, is ax squared plus bx plus c, where a is 1, b is 0, c is 0. Alright, so how you write that is just like that. Alright, y equals, and here we had 1x squared. Alright, everything else was 0. 0bx plus 0. Alright, so I don't need to write any of that. And then r squared equals, what was it, 1? Let's go back, 1, yep. Alright, so we're good to go. Alright, we're good to go. Let me ask you something. What do you think would happen if we were to put this in and we did the wrong calculations, alright? If we did the wrong calculations, meaning, let's say we said it was linear. I went to calculate, and I went to linear regression instead. Alright. Alright, see how this r squared is 0? That's not good. Alright, we don't want that. So that means we did it wrong. So anytime you do it, alright, and you're just guessing, And you're like, oh, it's a linear, and not r squared is 0. That's not right, guys. All right, that's not right. So that means you did something wrong. You need to go back, look at the problem, figure out if it's quadratic or cubic. All right, we don't want this, okay? Now, this last one, guys, we know is cubic or exponential. All right, so we're going to go ahead and we're going to put this in. This is column 1. This is column 2. All right, so back to the calculator. Stat. Edit. All right, let's clear our list again. I'm just doing this so you guys can see how to clear it. All right, clear list 1. List 2. Clear list 1. Oop. There we go. Now, I believe it was 1 through 5. All right, and then over here, go ahead, take a second, and enter your data right here. All right, I'm going to pause it for a second, and you guys put that in. All right, guys, so you should have it all entered into the calculator like this. Now, what you're going to do is press stat again and edit. No, I'm sorry, stat and calculations. All right, now this is exponential. All right, so listen, if you go to option 0, all right, exponential regression. All right, I know right here, guys, it says cubic, all right, but you can go to exponential to give you the actual equation. All right, so go to exponential regression right here. Hit enter. Same thing, list 1, list 2. Scroll all the way down to calculate. All right, and here's your equation right here. All right, we have 22,727.15. All right, and B is going to be 1.1. All right, raised to the power of x. So let's put that in. Y equals 22,727.15. All right, and B is 1.1, and it's going to be raised to the power of x. All right, like this. And then our r squared, guys. Let's talk about this. Our r squared. Y'all see how the r squared, guys, is 0.99. Excuse me, 0.99999999992. All right, so that's fine. All right, we're going to put that. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. All right, 9 nines. All right. Now, hypothetically, man, let's see if real quick we did linear regression instead of cubic. All right, I'm just going to show you. So stat again. All right, calculate linear regression right here, option 4, and calculate. All right, if you see how there's less nines right here. All right, the thing to remember with the exponential is the more nines, the better, because it means it's closer to 1. All right, you want to be as close to 1 as possible. So the more nines, the better. All right, now this tells us right here that we're not really right. All right, we need to explore another option. All right, and the option we had before with option 0 exponential gave us all those nines, which means we're really, really, really close to 1. Okay, really close to 1. All right. All right. So now let's see. If you're trying to decide which equation to use, calculate them all and find the one where r squared value is closer to, as we just said, closer to numeral uno. All right, closer to 1. All right, closer to 1. Okay, you want as close to 1 as possible. All right. Now, for this problem right here, guys, I'm actually slap this problem on another video. All right, and then that'll be it. So this is a U try. I'm going to work it out. So you guys tune into another video. All right.